So for the rest of our program, we've got a set of monitoring talks. I think that we were really happy to get these monitoring talks in an effort to sort of get some sense of what a monitoring, if there were one monitoring system to rule them all, what would that monitoring system look like? All right. So I guess our two speakers are from the University of Wisconsin, Scott Nolin and Andrew Wagner. Scott is the head of Technical Computing Group at University of Wisconsin Space Sciences and Engineering Center. The Technical Computing Group at SSEC provides complete computing support and leadership for the center and its research programs focused on geophysical research and technology to enhance our understanding of the atmosphere of Earth and other planets. Scott has been with the SSEC Technical Computing Group since joining the center in 1997 and has led the group since 2001. He received Bachelor of Science in Computing Engineering from the University of Florida in 1993. Andrew Wagner is a research systems administrator and member of the Technical Computing Group at the University of Wisconsin Space Sciences and Engineering Center. The Technical Computing Group provides complete computing support and leadership for the center and its research programs focused on geophysical research and technology. Have you heard this before? To enhance our understanding of the atmosphere of Earth and other planets. Andrew's been with SSEC Technical Computing Group since joining the center in 2013. Andrew received his Bachelor of Science in History and Political Science, hot damn, from the University of Wisconsin in 2009. Let's hear it for first liberal arts, and then right on. Let's hear it for Scott and Andrew and Lustre Metrics.
Okay, Andrew will be talking for the second part of this presentation. It's actually, he has more slides to go through, so I'll try not to hog all the time, but I might. First, just a little bit about SSEC. I'm not going to read all this information on the slide, but the picture here is a picture of our founder, Vern Sumi, and Explorer 7, the first satellite to put up a weather instrument into space. He's the father of satellite meteorology. So our work really focuses a lot on not just climate and meteorology, but remote sensing. And so with that, we work with a lot of satellite data. Excuse me. So why do we care about monitoring and metrics at SSEC? Because we have to deal with a lot of data. Now our data type is, just to give a little bit about what we do so you understand how we built for our use case. We have a lot of 30 to 200 megabyte files, process both with MPI for numerical weather prediction stuff and with simple computing. We do one of everything. We also have a large disk archive of this stuff. So Lustre really fits our work case perfectly in a lot of cases. Since starting working with Lustre in 2010, our storage has increased rapidly. We'll be adding another 4 petabytes or so this year. And we actually have quite a few file systems. We have a dozen. Only about 8 of those are super important. So for us monitoring, we need to look at a lot of different file systems. So that's why this is important for us at SSEC. And Lustre metrics are, well, I'm not going to be talking about a product or or some code that is the monitoring system for you. This is more about new techniques and approaches for monitoring. It's based really on work that's currently happening quite a bit in the cloud services space. And I think you may see some of the presentations following may use some similar tools or techniques. So we say Lustre metrics. Unfortunately, I think metrics means something very specific, but when you're searching Google and for this cloud services stuff, it has become its own word that means something else. What it's concerned with is the time series data, and we're concerned with Lustre time series data, and visualization of that data is a very important component for metric systems. So we will use that term to describe our work. It's a useful thing for you to know if you're looking at these techniques online. What it is, it's a time series database, similar to your round robin databases of whatever you want to measure. It's very easy to add or change metrics on the fly. and visualization dashboards for the analyst can customize them. And it becomes part of the normal workflow to, you start out with some dashboard, but that's just your starting point, and you dive in deeper, select what data you care about. Maybe you want to look at this export NID and its metadata operations. Maybe you want to look at a job. The point is that instead of just making a product, you have a process all the time. We're not going to talk about logs here. You can derive time series data from logs and feed them to a similar system, but that's probably better served with some other technologies. For a good overview, see Kalpak Shah's Lug 2014 presentation on log stash in Kibana. I also like to put a picture of logs on the screen if I can. So current Lustre monitoring tools, LMT, LTOP, XLTOP, Ganglia with CollectL, and vendor tools. These all work. We've used many of them at Space Science Engineering Center. So there's nothing wrong with them. If they serve all your needs, why I wouldn't bother changing it. But customizing them can be difficult, and they're not extremely flexible. We had some experience with Ganglia, and it works pretty well, and it's pretty easy to customize what you're collecting from both your Lustre servers and your compute nodes. But the visualization part of that I found hard to modify, certainly not on the fly or dynamically. Some advantages of these new methods. As I said, it's a technique. You know, it's not just an application. It's very flexible, and you can measure whatever you want. We'll focus here on Lustre metrics, but the nice thing about measuring whatever you want, you can then put graphs on top of each other of different things. So maybe you're looking at in the compute side of it, if you're not doing, you might be looking at like, what's my load on my compute servers? What's the valve position for my chiller? You can make a graph for that if you wanted to. Limitations of it, this is important to remember, or when you're looking at any of these things, if you get a system like this and you find the tools are nice, that's your hammer you try to hammer everything down with. It is not ideal for some cases. Reports, you can certainly make reports from time series databases, but that's not an integral function. So that's sort of a weakness. Similarly, archive of historical data. These are round-robin databases that lose resolution over time. So if you want to go see, your peak usage 10 years ago, that's not necessarily easy to do with a default install of this sort of thing. Also, temporary metrics. And by that I mean, when we're measuring things for a metric system, it's usually something that's there and persists. So maybe you have hundreds of thousands of compute nodes, and that would be a ton of storage, all those RRDs, but it's bounded, right? It's not unbounded. If you're doing Jobstats, which we will talk about, that's what I would call a temporary metric, meaning a job exists for a brief period of time and it goes away. So it doesn't really necessarily fit, and so you have to do some other things if you want to deal with that for the system we'll be talking about. One key to this really is iterative prototyping. That's how we develop the system. All of these tools, as I said, they come out of the web services world, where iterative prototyping is how they do everything. It's nice because what I was telling myself as I was trying different things was like, well, okay, what can we do? Once you get a base system, it's like, is this better than what I had before? If so, you feel okay about yourself. You're pretty far from the whole thing getting done, and you didn't waste your time. So you can scale up as you iterate to more and more and more metrics, or you can scale out if you need to. Here's an example of the workflow for the new metric system. Up in the lower right-hand corner, there's the analyst or the system administrator. That's a picture of someone actually from our center from years ago. On the upper left-hand corner, there's a developer. Now, those may be the same person. For our workflow, that's how we have it. You have a, excuse me. You have a monitoring target. You have some way to collect metrics into your backend system, and you have a visualization system. These divisions are somewhat arbitrary, but this gives you an idea of how it basically works. Say your analyst decides your dashboard is no good because you're the developer, don't know what he needs, and you're stupid or whatever. I need something else. He can make his own dashboard as long as the metrics are there. What if he doesn't have all the metrics? Well, the developer can go and add it to the system. Often the sysadmin is the analyst and the developer, in which case then the loop is even tighter. So tools for this system, starting over in the upper left here with the metrics collection. There's many ways to do it. Collect D is a common one. You can make your own script and send it to a socket. You can use CheckMK or Nagios performance data. You can use Ganglia, whatever way you can use ways you currently collect data, which is what we did, and send them to your backend system. Graphite is sort of the most popular and the first one of these that made this, this type of system common. That's what we used just because it was easy and there was a lot of stuff for it. There are some newer alternatives, OpenTSDB and InfluxDB. Those may have some important advantages for people. And then finally, you have a visualization system, and this is very important for the workflow we're talking about. Grafana is our favorite dashboard system. We've been using it. Graphite itself has a dashboard tool. When I first started prototyping this and I was working with graphite, I couldn't believe how easy it was to make graphs out of graphite with its own built-in tools, and because I'm used to the existing stuff we had. And then I used Grafana and I realized that graphite's existing tools are just insufficient or not nearly as good. So, but you can do that. You can also make a URL via the Graphite API and get data directly. Similarly, OpenTSDB and InfluxDB, I'm sure they have multiple methods to get data. Grafana works with one of those, I think OpenTSDB. And then finally, I'll mention Graph Explorer. I have the full URL though because it's sort of an unfortunately named project, but it's a very interesting project. Not necessarily even if you use it, but it addresses some of the weaknesses in graphite specifically, which is a lack of metadata on your metrics. And by metadata on metrics in this case, I mean like where did the data come from, what are its units, tags for it. And so that's pretty interesting. Next, we will talk about our use at SSEC, our case study, or Lustre metrics. Andrew is gonna excuse me. Andrew is gonna walk through several iterations of what we did. Now, our environment is about, we have hundreds of compute nodes, petabytes of storage, you know, tens of OSSs. You have 100,000 compute nodes, you're going to need to scale things differently. So, but this is an example of what works for us. Thanks.
Thank you, Scott. And thank you for the liberal arts shout out at the beginning of this. Fortunately, I realized that our computer overlords in the future wouldn't be real impressed with that and have moved on to bigger and better things. So now I'm doing this. So here at SSEC, before we could deploy the existing Lustre monitoring system we have, there's definitely some prerequisites that we had to have in place before it'd be possible to do this. One of those, configuration management, I'd imagine most people are already doing, whether that's Puppet, Salt, Ansible, Chef, whatever flavor you prefer. You're going to need that to be able to do that iterative prototyping and rapidly push out changes as you're going through testing. For hardware, you can start doing this type of testing with a very minimal investment. If you're just trying to figure out how to start measuring metrics, you can do it with a small VM. You can do it with a spare server if you want to scale things up, and if you need to scale things up further, well, you know, there's more of a hardware investment, but you can start small, and that's the important thing. When it comes to picking a graphite namespace, which is unique to sort of using graphite itself, you're going to go through a bunch of different versions of it. We can tell you that from experience. And we have some links later on in this presentation that'll give some good examples of what a graphite namespace looks like that we use, and that kind of explain things better than anything I can tell you right now. But most importantly, you have to decide what Lustre metrics you want to measure. For someone who is either just starting out in Lustre or doesn't have a lot of experience with existing tools, this can be a difficult challenge. John Hammond has a quote that Scott found, he spoke earlier. The problem with documenting Lustre stats is the sense of sorrow and horror one feels. I thought that was pretty hilarious, and the command line command that is listed on this slide, I'm not actually certain, I don't think it actually works anymore, but at one point in time it was a pretty dizzying array of results that you would get back from this, and it wasn't necessarily apparent what all of those different statistics did or what they meant. So where do you find out what Lustre statistics or Lustre metrics there are? Well, this is just sort of a general purpose list here. The manual's got stuff, plenty of previous lug and lad presentations. The mailing list has got stuff in the archives that can certainly help you. And I know Scott's even looked through the sources of tools that already exist, LMT and LLTop among them. And after we got through figuring out what we wanted to measure, Scott went through and created the first version of our monitoring system. And we decided we were going to monitor monitor metadata stats. And that's just because one of the most common modes of failure for our Lustre file systems was people crushing them with metadata operations. So that first version of our Lustre metrics monitoring was just a simple Perl script, ran on cron, sent data to a graphite socket. It was simple to write and simple to debug. Now, this is the workflow that version uses, and you can see it's a pretty simple set of lines here, and it resulted in this. Now, this is a Grafana dashboard that is plotting out all of our file systems and the metadata operations that are occurring on them. You can change this dashboard so that you could look at a specific file system and have it break down the metadata operations into things like reads and writes and opens and closes, and it'll display all of that. And this was our first version of our monitoring system, and it was immediately useful to us, a key part of iterative prototyping. Well, we don't want to just know about metadata stats. We also want to know what the heck the OSTs are doing. We want to be able to diagnose problems if we have an OST that's underperforming or misbehaving in some way. So we added other stats and have another dashboard that we can create. Now, the pop-out screen there on the upper right is displaying the write rate for all of the OSTs in the file system at that point in time. And you can see how it's created a graph that displays that over time. And that's just one tool that we can use to debug if a file system is misbehaving. And it gives you enough information to actually know something useful. Beyond the Lustre statistics themselves, or the Lustre metrics themselves, there's other things on the files, or on our servers that make up a Lustre file system that we want to know about. Things like CPU load and memory. And we were already collecting these via another tool, but we realized it would be helpful if you could actually plot those graphs alongside all of the other graphs that we're already collecting about the metrics in our Lustre file system. So we moved on to version 3 of our monitoring system. We changed from standalone Perl scripts to CheckMK local checks. Is anyone here familiar with Nagios or use it in their operations? Yeah, it's pretty widely used. Well, CheckMK is a configuration management system for Nagios. It makes your Nagios configurations on your Nagios server. Also runs on the server nodes themselves. It has a default set of checks that do things like monitor your CPU load and report back to your Nagios monitoring server. Well, you can also just put a script in a folder that the CheckMK client on the server will run, and it'll send that data back to the Nagios server too. This was really convenient for us because we were already operating this. If we collected Lustre monitoring data this way, we could just keep all of our data in a single system with a single set of monitoring tools. And we still get alerts and notifications provided by Nagios on that data if we so choose. So the new version of our Lustre monitoring system has a slightly more complicated workflow. Our CheckMK clients send data back to a distribution of monitoring tools called Open Monitoring Distribution. Just packages Nagios, CheckMK, PMP for Nagios, and a variety of other software packages together. Really easy to install and set up. And then we use a script called Graphios that Sean Sterling developed. That's on GitHub. You can go and check it out. That just pulls out a specific subset of Nagios data and pipes that data straight to Graphite. And then from there, we can interact with it via Grafana, exactly like we've done in all of our previous versions. So now you can see another type of dashboard that we are creating. We now can see the CPU usage percentage on our various Lustre file system components. And you could place that dashboard right below any of your other Lustre metric dashboards, and you could look for correlations between what's happening on your file system and CPU utilization. You could change that so you're looking at a single OSS and a single set of OSTs and really get in depth on this. And it's a really powerful way to visualize what's happening on your system. Well, beyond just raw MDS and OSS and OST stats, we wanted to know what exactly each individual Lustre export or client is doing to our file system. It's not enough to just know that something's going wrong with your file system. You want to know why. So it's usually easiest for tracking this stuff down if you know which client is actually misbehaving or causing all those metadata operations. So we added export stats to our monitoring system. Now, this dashboard here shows all of the metadata ops on a file system per export. And you can see how the graph lists the NID of the export and what it's doing in terms of metadata operations. So if you have a misbehaving client, it makes it pretty easy to figure out which one it is. But that's not it, or that's not all. We use Lustre in HPC settings. And a lot of times, it's not enough to just know the client. You may want to know what HPC job on a cluster is actually causing the problem. And that's where Jobstats comes in. Jobstats is something that you can turn on in Lustre, and it will then report metric data based on the job ID of the scheduler that you're using. Now, Jobstats are a little different than the other types of metrics we've been looking at. And the reason they're different is that you have a lot of jobs. A busy cluster can go through hundreds or thousands of jobs in a day. And each one of those jobs has its own set of metrics. If you're using time series databases like we are, each one of those metrics is a separate file. And for monitoring Lustre metrics, though, you may have hundreds of files per job easily. And that builds up over time and causes storage problems and visualization performance issues. If you're looking over the last week of Jobstats, it may be your visualization system may be trying to access metrics from tens of thousands of files, and that does not result in good performance for that system. So how do you deal with that? Well, you can keep a smaller window of data, which is how we deal with it. If you can just use a cron job to find an RM data files from those jobs that you don't need any longer. The job's been done for a week. Do you really need statistics on it? Maybe, maybe not. It depends on how you interact with your users on those jobs. You can also do something that Scott came up with, and it has to do with how Grafana builds dashboards for you. We were able to take the start and end time of jobs, and then based on that job ID, generate a unique URL for that job that would just show the data from that specific job when you put it into your browser and went to that Grafana instance. That made it a lot easier to analyze what was going on with those specific jobs, and I will show you a dashboard of that in a second. This first dashboard is just a top 10 average of the jobs with the highest metadata operations on a file system. And this is just an example here, but you can see how it could be pretty useful for figuring out what's happening on your file system while jobs are running. And this is an example dashboard of what we were able to generate with just looking at job IDs and specific jobs from that script. You can see exactly what that job is doing and how it's working. And it's pretty useful if you want to talk with your user about what's going on when a job is doing something in particular to your file system that you don't like. It's nice to be able to say, hey, 20 minutes into this job, you went through a cycle where you were going crazy with your metadata operations. Like, let's look at what the code is probably doing in that section and do something about it. So we've found these to be really powerful tools for optimizing what's happening on our file systems, and it's worked great for our scale of operations. Other people are going to have to do things differently, but we think it's important to share this information. So we're sharing this because we really believe in a community approach to doing this. We invested a lot of time in this. I know Scott has spent countless hours pouring through mailing list emails, the Lustre manual, source code, trying to find these metrics and figure out what they mean, how you get them, and what we should do to monitor them. So we want to see that work benefit other people, and we want to be able to benefit from other people's work too. We use the OpenSFS wiki to post some of the documentation of our work, just to kind of explain how we built our whole infrastructure out and how we arrived at the Lustre metrics that we're monitoring. It would be great if, now that OpenSFS has lustre.org, some of that stuff either gets moved over there or we'll put it there. But we'd love to see other people contribute to that too. So when someone else who's just new to this and doesn't have any idea what Lustre metrics they should be looking at and want to give a monitoring tool a try, have somewhere to turn. And that's something that we'd really like to see happen going forward. So these new techniques and tools that are available, and we just showed you examples of using Graphite and Grafana, are really powerful and can extend far beyond Lustre in terms of what you can monitor with them. And the nice thing about it is it lets you juxtapose it all together into a coherent whole that really can tell you what's going on in your clusters, in your file systems, and how they're working together. So that is all we have for you today. Scott and I would love to answer some questions for you if you guys have anything that you want to talk about.
Oh, I'll come.
Here's the mic.
Thank you. So my question is related to the possible comparison that you might make between this kind of tools for monitoring a file system and the IML tool that is sort of packaged by Intel. I mean, is there some overlapping, as I believe there is?
I don't know, because I haven't seen the IML tool. I've looked for some screenshots. Actually, early on, one of the things that we talked to Intel about was, could we just buy IML, or because we were aware of Chroma and stuff, and it doesn't really work that way. They were very open and nice, and actually even talking to their engineers, they gave us some information that helped us with our some of our other decisions. But so I don't know. I suspect it does. I think IML does more as far as you can configure stuff through it too. This is just purely monitoring.
Yeah.
But at the root of it, everyone's looking at the same stats files, right?
Right.
So,
That's
to me, the really important part, or the part which I think would be really nice and valuable, is the more knowledge into what the stats files are and what you do with them. That's really the interesting stuff. Everything else here, all the machinery around it, it's kind of fun to play with and it's cool, and essentially you can build some things that are very useful, but it's just the machinery, it's not the knowledge, is what I think matters.
Yeah, we're putting it out there so that anyone else who's interested in doing this can get done with the machinery building part as quickly as possible and get to the part where they're actually getting useful information about what's going on. Yeah.
Anyone else?
All right.
I want to thank you guys both, for the talk, but for your contribution to the community and your desire to share with others. So
thank you. If anyone wants to see an example of the thing live or wants to talk to us about it, just grab us
well,
at some point.
thanks a lot, guys.
Thank you. Thank you.